Dr. David Morgan, who's just an amazing mind and really on the forefront of particle physics. He talks to us about dark matter, dark energy, quark stars, some of this theory, mysteries of the universe type stuff. So from the simple stuff, star maps, what we know, concrete, to more theory. We're going to have a great show this week.
What you have to remember about astronomy is when you're looking at things that are very, very far away, you're looking back in time, right? When I look at a galaxy that's 1,000,000 light years away from me, I'm looking at the universe 1,000,000 years ago. When I look at a galaxy that's 1,000,000,000 light years away from me, I'm looking at that galaxy as it was, so to speak, 1,000,000,000 years ago. So if we look at the most distant things we can see through our telescopes, you're talking about things that are 8, 10 billion light years away. And so quasars are, the fact that we can see them at all, because they're so far away, means they're incredibly bright. And because they are so far away, we know we're looking at something that happened in the universe in the past. Whatever a quasar is, there's nothing like it near us, or that's all we would see when we looked up in the sky. So there's some sort of very violent event that happened only in the early universe that isn't happening anymore.
Has the dark side of the moon ever been photographed?
Oh, sure, many times. Well, there's no actual dark side because
There's
the
only
sun,
the far side of the
the
moon.
far side.
Do you believe those photographs were doctored?
Well, we don't have to. We don't care. No, we don't have to because we took our own pictures.
What? How did you take pictures of the
No,
far
I don't
side
mean
of the moon?
we, myself. I mean we on Earth, the United States and other countries,
Right.
including China and India out there right now.
Right.
So and we matched them with the original Russian pictures. See, you're right. When the Russians said, "Here's a picture of the far side of the moon," this is, come on, guy, you know. Yes, you just took a picture of the oatmeal bowl, you know. But no, they have been vindicated.
Both sides of the moon get sun. It's just that we only see one side, and about 14% of the other side.
Yeah, the moon does. You know,
Wow.
we can actually do it here if you're the sun.
Okay.
You're the Earth. Okay.
Okay.
I be the moon.
Okay.
Now, I can tell if I'm turning because when I turn around, I see all parts of the room. Would that be a fair way? Okay. You'll look at me. Okay. Stay put. Now, do you see my back head?
No.
But I am turning because I'm looking back at.
Right.
Okay. Looking down that way. So cool.
What we know about quasars now is that they have something to do with the early stages of formations of galaxies. And that when we look at galaxies today, even our own Milky Way galaxy, what we find in the center of that galaxy is a black hole. And not just an ordinary, like one star collapses and turns into a black hole, but a black hole with a mass of thousands or tens of thousands or hundreds of thousands or even millions of solar masses. So these things, what are called supermassive black holes, live at the center of the Milky Way and the Andromeda Galaxy and all these other galaxies that we see.
The Milky Way is one of billions of galaxies in the universe. What you have to remember about astronomy is when you're looking at things that are very, very far away, you're looking back in time. Right? When I look at a galaxy that's 1,000,000 light years away from me, I'm looking